This section is about the UVM factory. UVM factory override. UVM factory is a mechanism to improve the flexibility and scalability of the test bench by allowing the user to substitute an existing class object by any of its inherited child class object. For this purpose, the factory needs to know all the types of classes created within the test bench by a process called a registration. There are UVM macros that allow classes to be registered with the factory, and a method that allowed certain types of instances of a class object to be overridden by each derived types. A factory can provide an object of the type we specify. The factory override method looks like that. Set type override by type by name. Set instance override by type and by name. Method example. Shown below as an example test bench structure comprising of a base agent inside a base environment that is instantiated within the test class. We will try to use factory override method to override the base class with the child class. 1. Type override by type name. The following logo shown in a type override is configured and replaces base underscore agent with the child underscore agent. This is also evident from the info statement that prints type of the returned object. Second, 2. An instance override by type and name. It is the most useful when only a few instances of a given type has to be overridden. A type override by type will replace all instances of the given type by the new type as the simulation log. Why the UVM factory required? The new function is used to system Verilog to create an object, create a class object, and is perfectly valid to be used in the UVM as well. Assume that the existing test bench uses Wishbone version 1.0. Protocol data packet class is used throughout the test bench in components like driver, monitor, scoreboard, and any other sequences. If the Wishbone version 2.0 is released and test bench required to update and start using packet definition for the new protocol, there would be many places in the test bench that would require an update in code which can prove to be cumbersome. So UVM has a feature called factory, which allows to users to modify or substitute type of the items created by the factory without having to modify existing class instantiated. Instead of a text substitution of a class name of existing data packet, a child class object can be created that makes necessary modification for 2.0, and the factory can be used to return the newly defined class object in all class places within the test bench instead of the first one. So a preferred method of object creation the UVM test bench is by using create method. The practical example. To illustrate an example of a factory override, we will create an environment as shown above with a couple of different drivers, sequences, and data objects. The image shown above is default configuration. The sequencer region M agent 2 operate on sequence 3, while the other two operate on sequence 1 by default. Let us first define a base data packet and derive a child class for it. Now let us create a base driver class and extend two more driver classes, ETH drivers and the SPI driver. To show the effect of the factory override, we will keep these classes to have minimum data and method. And coming to the sequence, which will be executed by our sequencer, we will create two agents as described below. And so now that the agent has a base underscore driver as my agent to version 2 contains ETH driver, and all drivers with the sequencers initiated with the build phase and connected in the connect phase. The top container my underscore env is still left. And then we have put our component into boxes and arranged it everything. It's time to write the test, and this is where the factory override helps. We will be able to substitute drivers and data packets and a sequence by calling a few factory method. The results are for learning. The test will define the PKT override and driver style tree and the SEQ inst. Also note that the factory configuration is shown in the log. Thank you.